This is a video of the new generation LORETA viewer at Applied Neuroscience Incorporated. It was developed by Ernesto Soler in 2007. swLORETA in general has been around for quite a while, but this is a new viewer. This is the first time that swLORETA has been put into a viewer that is somewhat similar to the 2001 Key Institute LORETA viewer, but it has many enhanced features. As one can see here immediately, this is a realistic brain MRI. One can remove the Brodmann areas and just look at the MRI rather than with the Key Institute. It was an average of 305 normal individuals' MRIs, and it was very blurred, whereas you can see there's great detail that you can see in this individual MRI, and we also can activate Brodmann areas. Each one of these white boundaries is the boundary around a Brodmann area. And we can click a key at any of these Brodmann areas and read the Brodmann area down here. For example, that's Brodmann area 48 left. This happens to be at 5 cycles per second. The red are Z-scores that would be deviant from normal in an individual. This is a simulated brain, and in the future we'll be able to show a number of different pathological cases of strokes and brain injuries. But for now, this demonstrates how the new generation swLORETA viewer works. It's SW which stands for Standardized Weighted LORETA. It's weighted of an S-LORETA by allowing one to have depth. So you can get sources that actually are at the surface of the neocortex, say layers 1 to 3, and drill down all the way to layers 5 and 6. This is something that can only be done by swLORETA, not S-LORETA, which is projections at the surface, or regular LORETA. There's a number of features I'm going to be able to show because the Key Institute LORETA viewer, I tried to maintain, as I designed this, some continuity. So with that 2001 LORETA viewer at the Key Institute, put together by Roberto Pasquale Marquis. It's a fantastic program that's been around for 15 years, and there's hundreds of publications. Unfortunately, it's no longer supported by the Key Institute, and also Windows 10 does not always allow you to operate with it, and it appears to be in the future there'll be fewer and fewer computers and operating systems that allow you to use the Key Institute viewer, and so that was one of the motivations for us to get busy and write a new generation and with a very advanced technology compared to the 2001 view. You can go to the axial slices if you wish and navigate around and look at these different Brodmann areas. For example, this is Brodmann area 48 left. There's Brodmann area 39 left. There's Brodmann area 39 right. And so, as I'd mentioned, each of these boundaries here are boundaries around the Brodmann areas. We can calculate the center of these Brodmann areas to do analyses if we wish. You can look at the coronal view and navigate around in that coronal view or any of these views. That's Brodmann area 7. Here's the sagittal view. Here's a three-dimensional volume view. And then you can look at 3 of them, which is very similar to the Key Institute LORETA viewer. And then you can look at all 4, where you have the axial, coronal, and sagittal views along with a volume view. This is important because the volume view, for example, if you have a deep source in the left frontal lobe and a surface deviation from normal in the right parietal lobe, you can see that all at one time, whereas in the slices you're not able to do that. You can also look at all slices, the same kind of view of LORETA Key Institute, except in this case there's 12,700 voxels, whereas the Key Institute LORETA viewer is only, there's 2,394 voxels, and the swLORETA version has a little over 6,000 voxels. So this is twice the resolution, twice the number of voxels, and again, this is all dynamic. You can look at any of these regions and move your cursor around. Typically we're working a lot in the 4 view because you get a very good view of what's going on this way. but we also can evaluate these views by superimposing the planes, the coronal, sagittal, and horizontal or axial planes, and axial. So, for example, this is the axial plane. This is a coronal plane. I can adjust the axial plane down, and as I do, you will see this axial view change as we go down or up. Or we'll look at the sagittal view and move through the brain sagittally. Or we can move the coronal plane. You can see it change coronally, going up to the frontal lobes now. We go back to the occipital lobes. You have the ability to look at, just jump to one of the Brodmann areas. Let's say we want to look at Brodmann area 2, right. You can go there. Brodmann area 6 left, Brodmann area 10 left, etc. So you can go quickly to any of them, read out the values. You can also save to a file. You can do a right mouse click, save the images, and copy the text information that's in that box below here if you wish. We're going to move the coronal plane back a bit. And the other amazing feature is you can go to settings, and I'll just quickly show you have themes. Right now in a white theme, we can look at a gray theme. Or we can look at a black theme. And that you can see more detail this way, but you don't have to print this. You'll save a lot of ink if you are in the white or the light theme. You can also change your orientation if you wish. I can click here if you need to look at things just in terms of particular views of the brain. Here's going to be looking at the left hemisphere. And you can also make the cortex transparent and just look at the plane. So I'm going to make it transparent. And now when we look at the planes, you see the volume itself is gone, and all there is the images. In this case, this is the coronal plane, same as this one. Here is the axial plane, which is the same as this one. And of course, here's the sagittal plane, which is the same as the one right up above here. It's this one. By removing the volume, you can get more detail this way in 3 dimensions. We can click and see, well, where is this part of the brain? And then we can move through the volume in this manner. And that when you have a patient with certain symptoms, let's say dyslexia, and you want to evaluate the left angular gyrus, you'll be able to select left Brodmann area 39 or left Brodmann area 40, and you can immediately see that particular part of the brain and examine it in much more detail than you could in the past. You can sort by the number of the Brodmann area, by the hemisphere, left or right. You can sort by the z-scores themselves. In the future, we'll have the ability to save these z-scores, to be able to put them into LORETA, to LORETA neurofeedback for a protocol for biofeedback. We also will have a tab up here that says networks, in which you'll be able to select the anxiety network, the attention network, the default network, the memory networks, etc. And just click on them, and immediately you'll highlight the Brodmann areas that make up those networks, and you'll be able to explore those networks that are linked to the patient's symptoms. You'll be able to save the z-scores, order the z-scores, and put them into a protocol for neurofeedback as well. You can go to the max or the min. You can have, in the scale, you can change your threshold for your z-scores and look at different values. And also, as I mentioned, I'm going to go back to the volume so you can see the depth advantage of swLORETA. So now I'm going to make it not transparent at all. And here you see the cortex. So we can go down through the depth. We can, right now we are at the deep sources. Let's go back up, let's go up to the surface. And I also can, by changing the roller on the mouse, expand the size of the volume. I can click volume view, so that's all you're doing is looking at the volume. And then we're going to go from the depth of the cortex, and then we're going to move up from, this is layers 5 and 6 of the neocortex, and now we're moving up through the cortex towards the surface. It starts to get black there because that's the interface of the top of the cortex with the dura, and so there are no sources there. So we're going to go back down where most of the source in this case is located, deep in the cortex. And there's the fore-view again. And you can remove the axial coronal planes or put them back in. And adjust the frequency here, and again, go to wherever you wish. There'll be the other interesting thing is when you move your mouse over the color bar here, you can see exactly what the value of the z-score is. And of course, at any time you wish, you can go to your clipboard or save to a file and save the images, print the images, put them into a clinic report, etc. So